Here's the thing, so you get crack. You integrate it as soon as you get your crack. That's how it went down.
Okay, let's get started. Let me have your attention, please. Let's get started. I apologize for the lack of heat in this room. The weather turned cold, and the heat is not adjusted properly. It's my privilege to welcome you to the University of Tennessee Nuclear Engineering Department Colloquium Program. My name is Lee Dodds, and it's my privilege to introduce today's speaker, who is Mr. John Polcyn, who is the president of AECL Technologies. For those of you that don't know, AECL stands for Atomic Energy of Canada Limited. John was in the nuclear Navy for 6 years, from 1968 to 1974. After the nuclear Navy, he joined Newport News Shipbuilding, where he was for a couple of years refurbishing nuclear submarines and aircraft carriers. He came to the Tennessee Valley, joining GAY in 1976, and he was there for 11 years, where I think he met his wife, married a Tennessee girl. Excuse me, woman. I'm learning the proper protocol. Apologize, okay? Then he joined Flora Daniel in 1987, and he was with Flora Daniel until 1994. And then he joined Bechtel engineering consulting firm. That's, for those of you that don't know, Bechtel is the largest privately owned engineering design and construction firm in the world. He was with Bechtel from 1994 till June of 2003, and he rose to the position of vice president of the Bechtel company. And then in June of 2003, he joined AECL Technologies, where he now serves as the president of that company. The title of his presentation today is The Nuclear Renaissance, not a matter of if, but when. Ladies and gentlemen, please welcome Mr. John Polcyn.
Appreciate that nice introduction, and for those in cyberspace as well, welcome. This has been colleague week for me. I was actually at MIT yesterday, both students and faculty, and then we had an A&S Northeast Regional meeting last night in Lexington, Massachusetts. Had a real good turnout, and from here, actually, Lee told me I could take this to be in cyberspace. I've got Penn State on Friday, so I'm just going to show them this video, right, or the webcast, if you will. I'm going to wear two hats today. The American Nuclear Society President Larry Folke formed a special committee on Renaissance for nuclear energy last year. Previously, it was under OPD, the Operations and Power Division, with Ted Quinn and Kyle Turner. But because of the events of the last couple of years and the renewed interest in power, decided to form this special committee. And with that, we kind of adopted universities, if you will, and I took the opportunity to take University of Tennessee, Penn State, University of Virginia. MIT was for a different matter, actually, up there yesterday, but certainly trying to engage everybody. If anybody has any questions, yeah, I am recruiting, so we'll talk about that afterwards. These are exciting times. I have to tell you that, first I got to apologize. There was an article today in the Inside Washington. It's on www.energywashington.com. We've been accused, if you will, of complicating the state of new nuclear plant construction in the United States. Yeah, because we're a Canadian technology. We're non-U.S. So I guess I apologize for that, but yet I'm not. I think that there's not a one-size-fits-all sort of thing here. That I'll talk about our technology a little bit, but really I want to talk about the bigger picture sense of why now? What's new? What's different? I'll get used to this here in a minute. Let me start with this. Since I joined AECL Technologies, I've been to China several times and traveled quite a bit, and of course I did with Bechtel as well. But when you start thinking about what's happening in the world today, in the overall situation. I mean, it's absolutely surprising to me. Maybe you all are smarter than me. 1/3 of the world's population don't have access to energy, to electricity. Let me tell you something. Let me take China, for example. And we just finished 2 units in China in 2002, 2003. Still on 1 out of every 5 days are without power some portion of the day, 2, 4, 6 hours. They don't have enough power still today. They're building new nuclear. They have very aggressive plans going forward. The second one, again, 1/4 of the world's population don't have access to fresh water. That's going to be the next most precious commodity. And I'll talk about that in a little bit more detail, actually, because we are engaged right now on a cost-sharing basis with the Department of Energy through Texas A&M University, the TIACT, which is the Texas Institute for the Advancement of Chemical Technology. There's a number of chemical companies and refineries in the Texas Gulf Coast area. It's for the deployment of new nuclear power plants. And there's 3 things that are driving that their desire to proceed forward with us. And number 1 is the volatility of gas prices, which we'll talk about. Because with the pricing going up on natural gas and the demands going up, they're shutting down plants. And I think you probably would agree with me, there are certain chemicals we don't necessarily want manufactured offshore. We want to keep that here. The second thing is fresh water. There is actually a shortage of fresh water on the Texas Gulf Coast. So with that, we've got our moderator waste heat stream is pretty nicely accommodates desalinization. I think we're going to see more and more desalinization as time goes on, as water becomes more and more less available. The third thing is hydrogen. But that's the bottom of their list. Again, it's the cost of gas pricing, fresh water, and then hydrogen. The World Energy Council predicts that the global energy consumption will more than double by 2050. So where's the power coming from? Again, I'll talk a little bit here on my next slide. The demands are continuing to go up. Part of that's driven by webcasts, by internet. People are more and more attuned to what the rest of what we enjoy here in the United States, and there is a lot of jealousy. They want the same quality of life, the same standard of living that we enjoy. That's only going to cause that consumption to go up even more. China, with the world's largest population and the fastest growing economy, is going to have to add the equivalent of our entire grid system, of our entire generation system, within the next 25 years. Now think about that. That is a tremendous amount of growth. Countries like Canada, again, AECL Technologies is a subsidiary of Atomic Energy Canada. That is a Canadian Crown Corporation owned by the Canadian government. We get more natural gas, more oil from Canada than any other country in the world. But they're talking now about building LNG terminals and importing natural gas. We're doing that today in the U.S., LNG terminals. The issue with that is, do we want to really become dependent on natural gas, again, from unstable parts of the world, just like we have been on oil for the last 25, 30 years? Our oil consumption continues to go up. We're up at 60% today. So again, these are things that are going to drive the whole world going forward. This is a list that was compiled by Dr. John Sackett, working again with the ANS, listing the 10 problems for the next 50 years. Notice energy's right at the top. Water I already mentioned, food, right on down the line. Go to population. The world population today is 6 million. 2050, we're talking 8 to 10. Again, there's going to be more and more demand for energy. Let me move on here. The common thread to all this, again, is it underlies the entire living standard. I mentioned certainly the aspects of people recognizing the standard of living we have here. They are going to be building, and what we're trying to do is resurrect the nuclear power industry in the U.S. because we want to keep at least the technology here, keep the base here. We're losing a lot of that. We have over the last several years to both the Asia Rim and certainly the Asia Pacific area and also even Europe today with TVO and PIN 5. Again, the life expectancy of these countries that don't have adequate electricity, adequate energy, it's only 43 years old. So again, as they they start living longer with new power, if you will, with the new opportunities with both fresh water and electricity, the life expectancy is going to increase. So we're going to have to meet those demands. And certainly from an environmental standpoint, I think everybody from a global warming. I know Mar Fertel was here a few weeks ago talking about and Dan Kiter as well from Entergy, talking about the environmental impacts from a carbon standpoint. Air, water pollution, nuclear waste, all those things are going to, again, the common thread here is energy. It's causing conflict, has for years, and will continue. As these commodities become more and more scarce, or again, the gas demand increases, those prices are going to go up. There's going to be conflict over that. So we need to be thinking about those things in the bigger picture sense. And again, bottom line is, where will that power come from? Electrify the population that don't have it today and meet the future demand. Let's talk about nuclear power today. What's happening? We have a pretty stable nuclear power industry in the United States today, 103 operating nuclear power plants. Most of those, if not all of them, will extend their license. They were originally licensed for 40 years of operation. They will apply for a 20-year life extension, license renewal. So we'll get another 20 years out of them. And what's driven that is the performance of those units. For the most part, they've been written off. They're very economically attractive today, the current operating fleet. They're operating around the 90% capacity factors today. I think I've got a slide here that shows that next. But we had a little downturn last year, but that's because of reactor vessel head replacements, steam generators, things like that. The outages were a little bit longer. But that will, again, that just shows the investment that utilities are making today to maintain their asset, to extend the life of their asset going forward. Low production costs. I mean, I've got a slide here, and I think Dan or Mar probably showed it here over the last few weeks. But I just, again, want to share that with you because I want to make sure that everybody remembers that. Other than if Lee and I were taking a look at the river over lunch, I mean, the hydro certainly is the lowest cost. But there's areas right now in the country that Western United States and Bonneville Power Authority has had issues over the last couple of years because they haven't had the rainfall, they haven't had the snowfall. So there's and if you look at what happened in Brazil 2 years ago, there were hundreds of people that died because they had a drought situation. They were very overly dependent on hydro. So again, we've got to have a balanced portfolio here on generation. Western Europe, for the most part, is pursuing gas, wind options, except Finland and France. Finland, I think everybody knows, just announced the TVO to build Finland 5, their fifth nuclear power plant. Very wise decision, because in other words, they were going to be very heavily dependent on Russian gas. Again, if the demand goes up and Russia could sell that at a higher premium elsewhere, and they cut off that supply, if you will, to Finland, Finland would have suffered greatly. France, certainly they're looking at their new generation from an ETR standpoint. They're also very involved in high-temperature gas. They're probably going to bid the next solicitation that DOE comes out with for the high-temperature gas reactor at Idaho. They'll probably have a team. We are continuing to build today at ECL. We've been building for the last 20 years continuously, and I'll talk about that in a little bit more detail, but we're actually building a second unit in Romania, Cernavodă Unit 2, and negotiating a third unit. These are CANDU 6s. Been very well, very good operating units. We'll talk about that a little bit more. Russia's also pursuing further development of nuclear power, including exports to China. They're in negotiations with the Chinese right now for new plants. Certainly the Middle East, I think everybody's probably seen that in the newspapers. They went after Finland 5 very aggressively. They were the lowest cost option. Again, there's still some questions relative to their quality. so they were not successful in that regard. I already mentioned China, Asia. They're certainly on a fast track. They are a major recipient today of our technology and our expertise, our resources. When I was with Bechtel, I mean, they were part of the AECL team on Qinshan. Technology transfer is a major thing in China. You're probably aware Vice President Cheney is in China right now. He was certainly advocating Westinghouse AP1000 as late as yesterday. The only issue with that is China, like many other countries, don't want to be number one, serial number one on a new reactor that has not been built, has not operated. We are discussing with the Chinese right now further opportunities and probably a replication of the 2 units we just completed in December of 2002 and July of last year, and that is the CANDU 6. And again, from a waste standpoint, substantial progress has been made on spent fuel disposal. The Yucca Mountain licensing application is on track with the NRC. I'm not going to talk about from a standpoint, really, I'd like to have all that unused fuel out there, but won't go there today. Maybe in due course. I already mentioned the performance factors, 89.6 last year. A little bit of a drop from the year before, but as I said, it's because of steam generator replacements, reactor vessel head replacements. From a cost standpoint, again, hydro doesn't show up on here. It's actually lower, but let me think. Gary, the blue one doesn't show up, right? This one, that's oil. The green is gas. Nuclear and coal down here are certainly the lowest cost. Nuclear was 1.71 cents. There are utilities out there that are right at 1 cent, 1.1 cent. The better operating utilities. Those numbers, again, are continuing to come down, but what's offsetting some of that today, alarmingly enough, again, since 9/11, we have a number of utilities that are actually spending more on security costs today than they are on operation maintenance costs, or production costs. So even as we look at new generation, we're trying to figure out how to design these plants to be safer so that we have less security guards, so we have less of a security force, again, to keep the cost under control. We are, from an infrastructure standpoint, nuclear power plants are probably the safest thing we have out there. If you think about, if you drive north toward Johnson City and whatnot, and some of Morristown and some of the chemical plants and things like that, you get up around New York City. Believe me, it's scary when you see all the refineries and the chemical plants just outside, on North Jersey side, just outside New York City. Alarming. I think Marv certainly has covered this. I won't go into a lot of detail, but certainly, again, with increased production capability, capacity factors, and so forth, the power uprates that have been done, it's been the equivalent of adding 19 1,000 megawatt new units. That's just performance. I will say, if I go back to this slide here a minute, let's see. As we go forward in new generation space, this is really the starting point. The new plants that we design, that we build, have to start at the 90% plus capacity factors. We can't go back to where we were back in the 80s, down in below 60%. Economics don't work. Most of the models that have been run, I know DOE has had the Scully Capital run some models. Certainly we've run some models, utility customers, as have our competitors. Everything is based on at least 85% above. What we're offering, I'll talk about that in a little bit, is really 95%. That's the starting point. Again, if you go back and you look at the lessons learned, the areas that have caused problems on plants today, it's really on the BOP side. It's not on the nuclear side. It's not on the nuclear islands. You have to understand what those are, and then either engineered equipment or redundancies and so forth, maintain that high reliability. It's not an option. It's really the starting point. So what's new? What's different? This is an artist rendering of the ACR 700. Let me bounce back to MIT. I mentioned when I was there yesterday. I'm sure you've seen their report. Professor John Deutsch, Ernie Moniz, and the whole staff there. I mean, they're talking about the need of 1,500 new reactors by 2050, just to meet 25% of the projected growth in electricity demand. Think about those numbers a minute. Those are overwhelming. I think back in the late 80s or late 70s, early 80s, probably the most we were ever building in one year was 8 or 9. So you can see, I mean, just taking the difference. I mean, that's just to maintain basically where we are and meet 25% of the growth going forward. Again, the most rapid growth will occur in developing countries. Again, China. Korea has a very aggressive program today. They're building power plants today, their own version, if you will, of the old System 80. It's now at a 1,400 megawatt unit. Been very successful. It's a good model. But again, going back to fresh, clean water, it always keeps coming up. That is truly the next precious commodity, I think. Again, special consideration for deployment, I'll talk about that a little bit. The greatest growth is projected in transportation. I know that certainly Dan was in here talking about hydrogen. It will come. Is it going to be in the next 10 years, next 15 years? It's going to be out of ways. I think the demonstration plant that DOE is going to be putting out a solicitation for the high-temperature gas reactor at Idaho will be a starting point. It's going to be several years. I'm sure you all have your own opinions on that, and afterwards, I'd like to hear them. I mentioned the dependence on foreign oil. That's 60% and growing. Not a healthy situation. We have to figure out ways to mitigate that. In some areas of the country, as a matter of fact, both oil and gas cannot be burned for generation, for electricity purposes. For electricity purposes when it's used for heating. New Jersey has that law, for example. If it gets below a certain temperature, there's so many homes that are heated by gas, you can't burn the gas. You use the gas for generating electricity. Again, it is in our best interest to lead the development. Now, all these countries that I've talked about, mentioned, have taken our technology and done a pretty good job. I mean, if you look at France, I mean, almost 50% of their generation is nuclear power, and they don't have all those natural resources for other means to balance it out. Japan certainly is another one. Not a lot of natural resources. They're continuing to build gas as well. Even here in the United States, we've got a couple of utilities that they're building gas right now to meet their current demands. They're looking at new baseload generation, including nuclear. Again, for a couple of reasons. 85 to 90% of their customer base are retirees. They're on a fixed income. If gas prices continue to be as volatile as they are, I mean, you're going to have people making a decision: do I turn on the air conditioner today to stay alive? Do I buy my prescription medication, or do I buy food? If you look at what happened in France the year before last, tens of thousands of people died because no power. So, again, a critical situation. Economics of nuclear. I mentioned today's fleet, the current operating fleet, are very economical. I think you probably heard Dan mention Entergy's strategy relative to buying plants. Dominion's another one, Exelon, I mean, they're Constellation. They're a very attractive asset on a going forward basis because, again, they've primarily been written off, so they're making a lot of money. If you look at what's north of the border, Bruce Power, they took a lease on the Bruce plant from OPG, from Ontario Power Generation, formerly Ontario Hydro. They're making a tremendous amount of money. They've increased the output of the plants, the reliability, the safety. You have outside investors. Cameco's an investor in that. TransCanada is an investor in it. Those companies look at the long-term future for power. We are engaged with them on a study for new ACR 700s on that site right now. OPG also looking for new generation. But again, I'm really looking at a North American energy strategy here. You know, we are so connected with Canada. I mentioned the gas and the oil earlier. Right now, Ontario is a net importer for power because of some of their situations. And I'll talk about that a little bit more. I mean, we take a lot of shots about Pickering and the situation there. There's 3 units that are still down. They've been down for a couple of years now. I will tell you, it's not the technology, it's the management of it. And the analogy I use here is 2 things. When I was with TPA back in 1985, we shut down 3 units at Brown Spring and 2 at Sequoia that were licensed. It was for management reasons. It wasn't the technology. since those units have been back up and operating, they've been, premier operators or great operators, making a lot of money. If you take your car and you drive it 100,000 miles, you don't change oil, you don't change spark plugs, you don't change the tires, it's going to wear out. So again, these units were not maintained in a manner that certainly that we were accustomed here too. Oliver Kingsley at the Regulatory Information Conference several weeks ago, we had a session on 3 Mile Island. Oliver made note that since TMI, we've had 27 shutdowns here in the U.S. Davis Bessie, the latest one, is down for 2 years. D.C. Cook was down for a couple of years. We're bringing back Browns Ferry's being brought back right now by TV. It's been shut down 16 years. Again, but the economics work today. It's not the technology. The current fleet, again, high capacity factors, low operating maintenance costs that I showed you on that curve, on that chart, shortened outages. I think TVA today holds the world record on the shortest outage, 13.5 days, Brown Ferry. Exelon has certainly been in that whole framework in the 20-21 day time frame. Again, the more you keep that plant operating, the more revenue and profit you're generating. So we've learned how to operate the plants, certainly, and I think going forward basis, again, that's why I say the starting point is where we're talking about on that 90% capacity factor. The consolidations I've already mentioned. Now, what about new plants? They're not considered, whoops, I'm sorry, didn't go forward, did I? There we go. Today, they're not considered attractive economically. High capital costs. When you can build a gas-fired power plant in a very short period of time and get your revenue stream up quickly, that's why we've had, and I'll show a slide on that later and talk about that a little bit. What we're doing, and I'll talk about this because it's really a step process and how we're trying to shorten that cycle so that we can get nuclear where we need to be. Investment rate of return. CEOs today are not going to make a decision to build a new nuclear power plant if it takes 9 years, 10 years from the time he makes the decision until the time he gets it online. They can take that money that he was spent during that time frame and probably get a better return on it. So again, investment rate of return is a very critical item to chief executive officers today. Uncertainty in the licensing process. If you think about what happened during the first generation plants that we have here in the U.S., I hate to use Watts Bar for example. I think it's 26 years. I was assistant construction engineer on Watts Bar one time. But, no company out there can afford that today. It's got to be, it's like anything else, any other market, it's time to market. So I'll talk about a little bit what the industry's done there to address those issues, those sorts of things to really make it competitive on a going forward basis. Earnings per share dilution. Again, if you make that decision, it's really that construction period where you're spending a lot of money. Where you've got long lead type equipment, 1,500, 2,000 craft on site, you're paying them day in and day out. You're putting out a lot of money and you have nothing coming in return. So again, you're diluting your stock, if you will. Now, Wall Street's very critical today because of what happened last winter. So I'll talk about that in a minute. We've got to regain the confidence of Wall Street. I know Dan Kiter mentioned that probably 2 or 3 times in this discussion with you. It is a very critical thing, and I'll talk about some of the things we're doing to address those. The goals here: reduce the capital costs and construction times of new nuclear power plants. Capital costs less than $1,500. I'll just tell you that the product that we're offering right now here in the United States is at $1,255 for the first plant, the first twin. We get to our nth unit, but that's the fifth unit of a third twin, if you will. We're down right at $1,080, $1,090, and we're offering it on a firm price, firm schedule. That's very competitive. We'll talk about that in a little bit. Construction times less than 4 years. A number of the vendors out here have got those scheduled for, again, their nth of a kind plan. And you've got to be careful on the nth of a kind. That, like I said, it's our fifth unit. In some cases, it's the 8th unit. In some cases, it's all over the map. So you've got to understand that. What's different today? The existing plants were built under 10 CFR Part 50. It was a 2-step licensing process. And years ago, the industry went to the NRC and said, look, we'll never build another plant under that process. I'll use Shoreham as an example. Here's a plant that's fully completed, actually gone through low power ascension testing and never operated commercially. It was basically decommissioned. The anti-nukes out there want to see these utilities spend all their money, and they're going to wait till the last minute and then get some soft-hearted judge or some step, if you will. I mean, God forbid it's snail darter again, right? I'm sure everybody remembers. We just can't afford that. No utility out there is going to take that risk. But today we've got a Part 52 process. It's a one-step licensing process, most commonly referred to as COL, which means Combined Construction Operating License. I'll talk about that a little bit. The only problem here is that it is untested. So again, I'll talk about what we're doing as an industry to test that process. Most of the existing plants today were built in a cost of service environment, regulated environment. The same environment where if they had $20 million worth of inventory, they were actually getting paid, making money off of that because, again, they were able to charge the utility customers for that, for the inventory carrying costs. That equation just totally reversed today. Most plants will probably be built in a deregulated environment. Although there are a few utilities that are still in a regulated environment that their public service commissions are talking to them very seriously about building in it, or looking at it from a long-term standpoint. And we certainly encourage that. Quite honestly, and I'll use TVA as an example here, having been here at that time, we were actually designing the plants as we were building them. And then after 3 Mile Island, we were redesigning, and then rebuilding and redesigning. Today, we will have the first-of-a-kind engineering done on plants. It's not, again, not an option. It's a prerequisite to building. I'll talk about design certification a little bit in a minute on another slide. But all the designs that will be built will be certified by the NRC, but probably before they're. I mean, there is a way around that. You can do it as a part of the COL. But again, from a mitigation of risk standpoint, most utilities would look to a nuclear steam supplier, if you will, to have their design certified before even making any sort of decision. The technology is mature today. Again, we know how to operate the plants. I can't say that was always the case, but it certainly is today. We know the issues. We still have materials issues today, but again, I think the industry is addressing those. Alloy 600 is a perfect example. I mean, with the reactor vessel heads and the corrosion and so forth. Steam generators on tubing and that sort of thing. Those are items that we've replaced now. It's incumbent upon us to use that as a starting point, using all the lessons learned. And the Institute of Nuclear Power Operations is a great starting point. They have the reliability data system that, again, from any system you want to look at, any component you want to look at, they can tell you what the reliability factors were and what the problems were and what you might want to do to mitigate those. Really, the biggest challenge is and NRC is really pressing on this right now. Chairman Diaz and Commissioner Merrifield and McGaffin, complacency. We're doing so well right now. It's easy to get complacent. We can't. Because as soon as you let your guard down, something's going to happen. Davis Bessie is probably an example of that. They were a very good operating unit until that incident. And then, for every rock you turn over, there's 2 underneath. I mentioned AECL. We have one option. There are others out there, believe me. And it's not a one-size-fits-all. But we've been building nuclear power plants for the last 20 years continuously. The last 6 have been on or ahead of schedule and under budget. 4 units in Korea, Wolsong 1 through 4, and then Qinchon in China. And I got to believe if we can do that in those countries, I'm going to stab a little bit at the American pride here. I know we can do it here. We are far more productive, our craft are, our people are. We've used a lot of people in these other projects, but I know beyond a shadow of a doubt we can do it here. I'm a part of the NEI New Plant Task Force, and we had Deputy Undersecretary Bob Card maybe a year and a half ago, and I posed that same question to him. Why is it we can go get U.S. Exim financing, Japanese financing, UK financing, and build a nuclear power plant in China, but yet I can't have the same level playing field here? We're getting there. Things are looking. I'll talk about the energy bill and some of the things that are going on there in a minute. I mentioned Qinchon. Again, the first unit, I'll tell a story on our production guy, and I know Lee likes Neanderthal-type people. We had a construction manager that we were 100 days behind schedule one time. He stopped work. He called everybody in his office, and he had airline tickets laid out, kind of like the commercial. And he said, look, I've never been associated with a project that wasn't completed on schedule or on budget. This isn't going to be the first. Those of you that can't make that commitment to me, here's your airline ticket and head home. The first unit was 52 days ahead of schedule. The second one was 4 months ahead of schedule. They've been very good operating units. One thing about our technology, I'll talk about it again too, is we don't have refueling outages because we do online fueling. Now, we are in the first maintenance outage on Chinchon, the first unit. The first year was over 90% capacity factor. Again, this is the first one in China. So again, we're pretty confident in the technology as such. I mentioned the last 6 units built by ACL, ahead of schedule or on schedule and budget. Cernavoda, I already mentioned Unit 2 in Romania. It's currently on schedule on budget. We are actually negotiating the 3rd unit with them right now. So, now, what's stopping the utilities from ordering new plants today? I've covered some of this, but I wanted to just double back a little bit. Again, concerns about the time to market. No CEO is going to make that decision and then wait 9 years. Just can't do it. Earnings per share dilution. Again, Wall Street likes these current plants. NEI goes up probably once a quarter, meets with Wall Street, meets with the rating agencies and so forth. Really tells a good story, showing all the slides that I talked about with the high capacity factors, low O&M costs and so forth. That story sells real well, but they still have question marks about new. Candidly, we've been up, made some trips, meeting with Jim Asselstein at Lehman Brothers and Citicorp and others. What they told us is if you offer a plan on a firm price, firm schedule, that certainly mitigates a good portion of the risk. We are doing that today. That's what we've offered utilities here in the U.S. We have a premier team, if you will. It's AECL, and again, that's a Canadian Crown Corporation owned by the Canadian government. Bechtel Power, which Lee mentioned, which I used to work for. It is the largest engineering construction company, privately owned in the world. They've been involved in over 60,000 megawatts of nuclear power around the world, primarily here in the United States. And then Hitachi. We have, Chinchon has a Hitachi turbine, a lot of major equipment. Hitachi's a $64 billion a year company. Bechtel's probably a 20 billion plus. That has a lot of credibility with Wall Street, plus the fact that we have built plants on schedule, ahead of schedule, on budget. Very important. Questions about the administration and congressional support. Let me just tell you, we're making progress here. I'll talk about the energy bill a little bit more in detail, but for those that, just to make things clear, Dominion has submitted a proposal to the Department of Energy for a cost share to go to the COL, the Combined Construction Operating License, using the ACR 700 technology at North Anna. There's a consortium of 5 utilities and 2 reactor vendors, and that is Exelon, Entergy, Southern Constellation, and Electricité de France, EDF, along with Westinghouse and GE, that has made an announcement of their intent to form a consortium and then take a look at the AP1000 and ESVWR for potential deployment. Actually, TVA is a silent partner on that, if you will. I think they've offered to provide people in kind. Again, we think there's room for both. We want the entire industry to be successful. There is no person in this world that has been more supportive of the nuclear power than Senator Pete Domenici. He's the one that's been pushing the bill, and his staff and whatnot. And I'll talk about that a little bit more. There's some things going on right now. It's been a little quiet since the 9/11 hearings and some of the other things. Certainly, Senator Bill Frist has been very key in working with Senator Domenici. I think you'll see some things happen. They're on their Easter recess this week. They'll be back in session next week, but I'll talk about that. A lack of incentives. We haven't really had a level playing field, and we're not asking for handouts or anything like that, but to get this thing kick-started, the industry has asked for production tax credits to be a part of the bill for the first 6,000 megawatts, and then we think beyond that we can self-sustain the industry moving forward. The uncertainty of cost and schedule, I've already really talked about what we've been able to offer. And the bigger issue there, again, is the licensing process, the Part 52, the COL. We're going to ask DOE to really step up there and help us because, again, if it's something, we can control the engineering, we can control the construction, we can deliver the plan on time. If we can't get it through the licensing process, it's all for naught. So again, we're working with the administration, with Congress on doing that. So that's just a validation, if you will, of the Part 52 process. Let me just double back a little bit with AECL. I mean, the first project that we're offering up is on a 60-month schedule, and I'm talking about from a contract signing date to commercial operation. Construction period's right about 48 months. On the nth unit, again, that's that fifth one, the first of the third twin. We're talking about 48 months. That's, again, from contract signing date to commercial operation. Construction period now is about 36 months. I'll talk about how we get there. Firm price, really is $12.55. I put down there $1,300. There's some things. The reason I put that there, caveated a little bit, because we are going through design certification right now with the NRC. Our design is something the NRC has not seen here in the U.S. Although it is a light water reactor with heavy water for moderation, the policies and the requirements we have in the U.S. don't govern that type of technology, just like they wouldn't on the GTMHR or the pebble bed. There's some different things that the NRC has to change thinking on a little bit, and they've been very, very good about that. We're actually going down a dual path right now because we're going through a similar process in Canada with the Canadian Nuclear Safety Commission. Again, Chairman Diaz, Commissioner Merrifield, and Commissioner McGafkin have been very supportive of that. They have the NRC working with the Canadian Nuclear Safety Commission because these people understand the technology. This is just an evolutionary thing. We've gone from heavy water coolant, heavy water moderation to light water coolant, heavy water moderation. We've gone from natural uranium fuel to slightly enriched 2.1%. We've gone from a positive weight coefficient to a negative weight. So there are some things that are different, but again, the Canadian Nuclear Safety Commission understands the technology. So what Chairman Diaz said is, look, go to Canada, look at their documentation, look at their basis for acceptance from a safety standpoint, why they accepted things, why they did certain things. We have also offered, we have a thermal hydraulic facility, RDM-14, up in Winnipeg. We've offered full use of that to the NRC, whatever kind of tests they want to see run. We have full loop. And one nice thing about AECL is they also operate two labs. One's the Canadian National Laboratory, where they've done a lot of work for the Navy nuclear U.S. Navy nuclear program, Chalk River. We're an open book. We've given them, when they've asked for things, Katina code, for example, we've given it to them and trained them relative to the ACR design. Our business model, I'll talk about it a little bit. We're willing to take an equity interest in the plant. We're willing to work in a number of different ways to make this attractive financially to U.S. customers. We have Hitachi, for example, is very willing to do that. Cameco, again, they're a 32% owner in Bruce Power, in the Bruce Station, 8 units. They also just made an offer on South Texas Unit 1 and 2 for a 25% share. They are trying to invest in the future to make sure, again, these plants stay operating because they're going to sell uranium. They're the largest uranium mining company in the world. So it's in their best interest. We have got some very creative approaches that we work with our customers on, again, to address the earnings per share dilution issue. Certain things that we're offering to do during the construction phase. Again, just shortening that construction is a major impact, bringing that dilution issue down. And then same thing with IRR. There's some things that we're willing to do there. Certainly, if the energy bill comes about and there's production tax credits, that just makes everything work that much better. Proven performance. Let me just tell you again. The CANDU 6 units today have about an 84% lifetime capacity factor. I'm not including Pickering in that, just like, again, we in the U.S. didn't include Davis-Besse for those 2 years, or Brownsburg Unit 1 for 16 years, et cetera, et cetera. So, okay, we'll play with that. If you throw the Pickering units in there, very honestly, it comes down to about 60%. But again, I'm just being openly honest. The technology is sound. This is really a simple machine. And I think Mike Savard was here about a year ago. Mike works for me, and I think he kind of gave you a technical overview. If you'd like to have that sometime again later, if it's a new crowd, by all means, we'd be willing to do that. Modular construction. Well, let me tell you what we really learned on Chinchan. I mentioned our Neanderthal construction guy. We learned about open-top construction, if you will, and modules. Today we have redesigned the ACR 700 to be modular. We've talked to the shipyards, Electric Boat up in Groton, Connecticut, Newport News Shipbuilding and Dry Dock Company. Hitachi actually has a module factory in Japan. They're duplicating that in Winnipeg, north of the border. People are really interested. And Salda, who's a partner of ours on Cernavodă in Romania, just bought the Ingersoll Rand facility south of Chicago. They want to build everything. And I will just tell you right now that if we were to get an order in the U.S. and the utility that we sold to wanted maximum American content, we could probably do 95%. The only thing we could not build here in the U.S. is the steam generator, and that would be either BMW Canada or Japan or Korea or perhaps France. Again, we don't have a reactor vessel. We've got pressure tubes, horizontal. I mean, we can build all those things here. And that's one of the strategies we've used from a localization standpoint in Korea and in China and so forth. Now, there's costs associated with it if you want to buy fully American. Kind of like that American car, you know, you go in, get into, it's really not American at all, right? Open top construction, again, we've really compartmentalized. We have sliced and diced our schedule 15 ways, and we've sequenced this thing and to the point we've got workarounds. That's why we can offer that fixed price, fixed schedule, firm price, firm schedule. Know we can deliver. Know that we can get to 36 months. Show you a detailed schedule, exactly how we get there. I can show you an animated video, exactly how this whole thing comes together. It's almost like an erector set or Tinker Toys, but it works. We are designing this thing for a 3-year operational cycle. Again, I told you we don't have refueling now. Just one of the things that's attractive to some of the utilities here in the U.S. is that fact that we have online fueling. Let's take a day in May in Tennessee and it's 95 degrees and you've got an outage schedule, a maintenance outage schedule, and you decide you really can't come down because you need the power. Okay, and just keep fueling, keep running. 2 months, another month, you know, however long you want to. You have some flexibility. Again, I mentioned the balance of plant. That's where the majority of the issues are on almost every technology. And I've done some research again through the NPRDS and INPO and whatnot. It's BOPs where the forced outages occur. We're addressing those things very aggressively. We're looking at a 21-day maintenance outage every 3 years. Got that down, and that's a turbine tear down, put back together in the whole 9 yards. I mentioned the online fueling, the 2.1% enriched fuel. Our fuel costs are probably 10 to 12% lower than many of our competition because of that. You know, their enrichment's probably 4.7, 4.8 up in that type. I put down here 1.5% annual forced outage rate. That's probably utilities really learned how to play this game in the U.S. That criteria will probably change because now they don't have forced outages. If they know they got to come down, they call it a planned outage. So it doesn't come into the forced outage rate. Right? But again, it's the reliability we're talking about here. Big item today, and going back to fuel a minute too, with the plants running where they are at up in the 90% capacity factor, we're running these plants longer and harder than we ever have. And they're starting to have some fuel issues. If we were to have that, again, we'd pop the leaker out online and keep on moving. We have a pretty close monitoring system. I mean, you know, as we're refueling and whatnot, we see some changes. You know, okay, if we've got a bad bundle, we pop it out. Keep on going. No boron and reactor coolant system. A lot of people like that. If you think about what's happened from a material standpoint on degradation of reactor vessel heads and so forth, that's pretty attractive. I already mentioned the horizontal pressure tubes. We don't really have a reactor vessel as such. The light water coolant, heavy water moderation. We've really taken the best of the can-do technologies, if you will, and light water, PWR technology. Made it work. Okay, let's talk about from a political standpoint a little bit. The energy policy, actually the energy bill and the case for new nuclear power plants is coming about. We actually have an NEI New Plant Task Force meeting next week. Deputy Secretary Kyle McClure will be there along with Mr. Peacock from OMB and a couple Senate staffers and whatnot. We're getting to where we really need to be from a business case standpoint and a policy standpoint. There are, and I'll get to the slide in a minute, but there is a need for new baseload in the U.S. You know, we really haven't built a baseload plant in probably 20 years. I know Dan showed this slide, but I'm going to show it again on the overdependence we have on gas today. If you look at where it's at, and I'll give you an example there. North of the border in Alberta, it's the second largest oil reserve in the world. It's called the tar sand. The Canadians are burning natural gas to make steam for heat extraction to get the oil out of the tar sand. Burning one natural resource to another. Huge volumes. we want to build an ACR there to make steam, and we're talking with the government about that. Again, I talked about earlier the stability of supply. Again, base load here. I'm not talking about peak. And clean air concerns. The government in Ontario that was just elected was elected based on shutting down all their coal-fired power plants by the end of 2007. They put up some windmills on the lakes. Let me tell you something, they're ugly and they want them torn down already. You know how many windmills you'd have to build in order to replace 5,000 megawatts? Unsightly. And then again, the volatility of gas prices. That's it. This administration's the first one I can remember in my life where we've had support for nuclear power. Again, I mentioned Vice President Cheney yesterday in China, talking with the Chinese government about AP 1000s. President Bush, Vice President Cheney, Secretary of Energy Abraham, the administration wants an energy policy that's very robust nuclear component, and we need that. We'll talk about that a little bit more. Here's some of the government actions that we're looking for, and NEI has been a very strong proponent of this, leading the industry, helping on this. We know that we're going to have to start making some decisions here. I mentioned the gas situation. If we're going to bring plants on in that 2012, 2015 time frame, right now is the time to make that decision. Now, this first one is going to take some time because it's going to be testing the Part 52 process, the COL process I talked about. DOE, actually, because of Vice President Cheney and the nuclear or energy policy developed when he first came into office, MP 2010 was born. I'll talk about that in a minute. It talks about the technology development and the licensing process demonstration. I've got a chart here we'll go through. And again, within Congress, I'll talk about this in more detail. The nuclear provisions in the bill need to include financial incentives to address those business risks. The first thing we really ask for is that with the bill where it is, there's no incentives in there right now. The first thing we got to do is get it out. You know, it's passed the House. Fell two votes short in the Senate for a cloture vote. At which time, then you just need a simple majority. The strategy here is now, when they come back off of recess, working with Senator Bill Frist, working with Senator Tom Daschle, is to get that, to make some changes. We pulled a lot out, but to get that cloture vote taken, and then go back to conference with the House. At that point in time, the strategy is to input them the production tax credits as a minimum. And then you can make everybody can pretty much make that financial model work. Beyond that, very honestly, we're going to need the investment tax credits because that's what will help most address that construction period. Got to have some incentives there to make that model work. Accelerated depreciation. Right now, we're on a 15-year cycle. Everybody else, I think I've got a slide in here on this. Maybe I thought I did, but everybody else is on a 15-year or a 7-year. Excuse me. We're handicapped. So again, from a recovery standpoint, it takes twice as long. All we are asking for in that regard is equal footing, a level playing field. That's a tax code change. So again, the Senate are working on tax code changes, and I'll talk about that. The industry really is in a 3-year. At the end of the third year of the plan to enable new nuclear power to become a reality, with a proper business case. And again, the current focus by all of us has been resolving the investment and the financial issues I've already mentioned, achieving the cost and schedule certainty. I think I'll talk about that in a second. There's been a couple of studies that have gone on on a cost sharing basis with the Department of Energy that are helping bringing that about with some of the other technologies. And again, the validation of the COL or the Part 52 licensing process. This is kind of redundant. I apologize. I mentioned this earlier about the incentives to help improve the potential for decisions to build nuclear power plants. So again, the first 6,000 megawatts. We're not asking for here or after. Again, just kind of a kickstart. Then we think that there will be a sustained investment in plants because we'll be able to prove that we can deliver them on time and on budget. The tax code changes I talked about, again, is changing that current 15-year depreciation schedule to 7. Again, chemical plants, refineries, on the major capital projects that they're doing today and new builds, that's what they get. I mentioned the nuclear power industry DOE or cost-sharing efforts. There's a study, actually TVA is a part of it, with Entergy and Dominion and Bechtel. Actually, it's the third bullet down. They're doing an evaluation of the construction schedule. MPR Associates is also doing an independent one for DOE. Again, taking a look at the schedule certainty, the cost certainty. Andy Patterson and Scully Capital also have done it, looked at it from a business case standpoint, done an evaluation for the Department of Energy. I've already talked about the providers offering overnight capital costs in the range of $1,000 to $1,200. Again, that's for that nth of unit, not the first one. Certainly ours is $1,255 for the first one, but the others are a little bit longer lead time to get to that 1,000. Again, the overarching goal here is to bring new nuclear power plants in within a 6-year time frame. Again, that's from the contract signing date, if you will, to the actual commercial operation. I mentioned a step process here. Let me just talk about that a minute. There are 3 designs that were certified under the Advanced Light Water Reactor program several years ago, and that was the ABWR, the AP600, and the System 80. Here's where the government has a problem. All those designs were certified, but none were ever built in the United States. They spent probably close to $1 billion on a cost-sharing basis with the industry, those designs certified. Again, there's a big red flag that goes up. There's actually 6 more that are in various stages of certification right now. The Westinghouse AP1000 is probably this year yet. We are in the pre-application stage with PCR 700. What I mean by that is we're working with the NRC. We've identified our issues, our differences. So we're trying to identify path forward for closure on those issues before we formally submit for design certification, which will probably be the end of this year, early part of next. The CMHR, gas turbine modular helium reactor, which is a design. ESBWR from GE. That used to be European Simplified Boiling Water Reactor. I think today now it's Economical Simplified Boiling Water. Framatome's SWR1000, and then you've probably heard of the double-bed modular reactor. The next step that people are taking, again, 3 utilities filed for early site permit. Dominion for North Anna, Exelon for Clinton, and Entergy for Grand Gulf. I've already mentioned about the construction schedules and the business cases. The next step that I mentioned when I first started off was, again, the demonstration of the Part 52 process. One utility, Dominion, has submitted to the DOE, that was on March 17th, for a COL demonstration project, if you will, using the ACR 700, using North Anna. That's not to say they're going to build. They haven't made that decision. Again, it's a long time frame here. It's about a 5-year process before it could be 2008 time frame that they would actually be in a position to make a decision based on having gone through this first process. And then the consortium that I mentioned earlier, Exelon, Entergy, Southern Constellation, EDF, and Westinghouse and GE. Of course, the next thing, and this is not an insignificant item, is to complete the first kind engineering on the designs. That's probably a $300 to $400 million process in itself. And then actually build a plant. And then the last one is the ITAC process. That's the inspection, test, and acceptance criteria. When you go in with your COL, you identify with the NRC the inspections and tests that you're going to perform to show that you complied with your COL permit, your license. And then you're supposed to be able to go operational. To enter into commercial operation. I mentioned the gas thing. I know you all have seen this before. If you look over the last 7, 8 years, all we've been building is gas. That's what the red line in this chart represents. It's really an overdependence on gas. We've got to balance out that portfolio. Because what happens now is with the gas volatility pricing, we become non-competitive around the world, all the industries. Because if the prices go up, the cost of the products go up, we can't sell it worldwide. We've got to balance that out. So, having said all that, let me just finish here. What can you do? I encourage you to get a hold of Senator Lamar Alexander, Senator Bill Frist. Let him hear your voice. Let him know how you feel. And the encouraging thing is college graduates have a 60% plus favorability for new nuclear. They understand the benefits of nuclear. Email them or call them. Call their offices. I mentioned the energy bill. There's actually an energy tax package that will be addressed when they come back off the recess. Again, just to get that cloture vote, to get it to conference, so that in conference they can get the production tax credits put in. That's the way the process works. Senator Domenici is calling this tax bill and these incentives really a jobs creation bill. He's saying it will create 650,000 jobs. He's saying if you vote against it, you're really voting against jobs for America. This is important for the next first step, if you will. Again, support your A&S initiatives. It's up to us. Lee and I talked about this over lunch. We failed the industry because we haven't educated the public as well as we should have on the benefits of nuclear power. I'm asking you to help, to do your part, and we're going to need it for the future if we're going to have the kind of future we really are looking for. And you are the future, right there. Let's make a difference together. It's up to you. That's all I have. Thanks a lot for letting me talk to you.
Okay, we have time for questions. I have a question. Having worked around heavy water reactors, who supplies the heavy water? Something that's replenished, reprocessed, or is it a fixed amount initially and then it's there for the life of the plant?
AECL will provide the heavy water leak, and no, there is evaporation and there's leakage. I mean, probably a couple tons a year that be replenished. But the first load, AECL certainly provides. There is plenty out there today. You and I talked about one source earlier. I mean, there's some treated water that can be cleaned up that can produce a good bit of heavy water for application and use.
Any other questions?
Yes,
Mario?
What do you think is the biggest stumbling block, Part 52 validation?
just the actual demonstration. I'll be honest with you, too. We have actually two law firms taking Part 52, whatever loopholes there might be, so we can close them before we actually get into it. And I'm sure they're there, because this was, 10 years ago that Part 52 was brought into being. I'm just worried about that soft-hearted judge, at the 11th hour.
You know where those holes are.
We do. We're getting there. I can't say we know where all of them are, but we're trying to address those now, taking an active approach on this thing.
When would the plus the ACI be abused?
I'm going to answer that this way. Hopefully north of the border in Ontario. It would make life easier for me here in the U.S. because then I'd have a simulator or a place to send U.S. operators for training. That would make my life easier. Here in the U.S., I don't know. What, betting man?
Yeah, one of the existing
Power plant sites? That would be my guess. Sir.
Okay. Before we adjourn, let me put a plug in for our next colloquium, which is our last colloquium. It's next week. We have Gail Matson, who is former president of the National Society of Women Engineers. And one of my objectives in inviting her is to encourage more young women to get into engineering in general and nuclear engineering in particular. Here next week, I encourage everyone to attend. Unfortunately, I won't be here. Dr. Miller will handle the introduction. Again, before we adjourn, let me remind you that we do have refreshments downstairs, and everyone is invited. And let's express our appreciation again to John for his service.
I happen to be a member of the
Oh, me too.
They actually take it. Larry, how are you?
Oh, sorry I was late.
Oh, that's
I had a meeting over North Ridge.
Good to see you. How you doing?
That's all.
I saw a copy. I don't have
Oh, my. There's a little more work. And,
You want to talk about